Namaste dosto, welcome to my YouTube channel called IVD Manufacturing. So today we'll be discussing on a topic called how to calculate the number of days required to perform the accelerated stability studies for your IVD based product, not via any software, not through any calculator, but through a simple Excel file which everyone will have their access either in their MacBook or in their laptop respectively. So dosto, before we start today's lecture, let us understand what is the meaning of the accelerated stability study and why it is required. So accelerated study is carried out to ascertain the storage condition and the expiry. The acceleration temperature shall depend on the number of upper limits of the claimed storage temperature, which formula is mainly useful in calculating the accelerated. None and all, it is the Q10 formula, my friends. So the temperature and the duration of the exposure of a product to the accelerated condition is derived from the Q10 formula. Now assuming you as a manufacturer have done the manufacturing of an RT-PCR kit which claims a storage condition of a temperature of 20 degrees Celsius, claiming a shelf life for the 12 months. But in order to claim this shelf life for 12 months, I as a manufacturer need to perform the accelerated stability studies at least for the minimum of 13 months. 1 month as a safer side, as a backup. So in this case, my target expiry would be 13 months in calculating the accelerated stability studies, not the 12 months. So let's understand what are the various parameters which falls under the Q10 formula. First one is a T1. T1 is the recommended temperature for the storage, which in this case would be minus 20 degrees Celsius as claimed by the manufacturer. T2. T2 is the accelerated temperature set for the degradation. In this case, I am going to assume either 5 degrees Celsius or 25 degrees Celsius. What is N? N is equal to T2 minus T1 divided by 10. Right? Now let's calculate the N. So I am going to calculate the N factor, keeping in mind that I have assumed a degradation temperature of 5 degree and 25 degrees Celsius. So for the 5 degree, let's say what will be the N coming throughout that factor, the N degradation factor. It is 2.5, whereas for 25 degree my N factor is going to come as 4.5. Now let's start calculating the ST1. ST1 is the number of days a product would be stable at a target storage temperature, whereas ST2 is the number of days a product found to be stable at a selected stress temperature, my friends. So I hope it is clear. I am calculating two options. In option 1, I am going to calculate what are the number of days where my product will be found to be stable at a given claim storage condition, whereas in option 2, I am going to calculate what are the number of days where my product would be stable at a stress condition, which is my 5 degree and 25 degrees Celsius. Now calculating ST1 equals to ST2 multiplied by Q10 raised to the power n, where Q10 would be 2 for the biological products. In this case, since my kit was the RT-PCR kit which falls under the biological products. So Q10 equal to 2 raised to power 2.5, where it was one of the NAND factor which comes as 5.65, whereas at 4.5 N it will come as 22.67. So now the following table would emerge in this case. Assuming that my storage temperature is at 5 degrees Celsius, I mean the stress conditions. So my Q10 factor would be, in this case, would be 5.65. I am going to perform my accelerated stability studies after every 1 week. So you can see, my friends, I have assumed that the number of days a product found to be stable at a selected stress temperature. So I am going to calculate the number of days in terms of week. So 7 days becomes 1 week, followed by another 7 days becomes the second week, which is a 14 days. In this way, I am going to drag on this number of days by adding 7. But whereas I am going to keep this Q10 factor constant, which is 5.65 throughout the rows. And then how my number of days expiry would come. So in the first week, if I am going to perform the accelerated stability studies on my IVD product, and if it found to be meeting the required specification against the IFU, the intended use, I am going to give an expiry for the 39.55, which is a 40 days approximately. Assuming that my product get passed in second round of accelerated stability study, which falls under the second week, which is 14 day, I'll be able to give an expiry for the 79 days. So my friends, you can see like at 70 days, which is at 10 weeks, I can give a claim shelf life for the 395.5 days, which was my target to calculate. As I told you, my product claim shelf life was for the 12 months, but I was supposed to calculate this shelf life for the 13 months. So now there were 10 time points. You can assume, like, see, if I drag this up, it becomes 10 time points. Now, assuming I am performing the accelerated stability studies at 25 degrees Celsius, because see my friends, when you perform at 5 degree, the changes which is going to occur in the product due to the stress condition on week basis, you will be able to at least capture, you will be able to at least analyze, right? But a major drift in the change while you perform the accelerated stability study at a higher temperature or a higher stress, you won't be able to figure out what was the actual cause for that failure. Though the number of time points would get decreased because you have maintained a higher temperature against the product environment. So when I say at 25 degrees Celsius, my Q10 factor would become 22.67 in this case. Assuming I am going to perform my first week of accelerated stability study at the end of 1 week, which is a 7 day, I'll be able to give the claim shelf life for the 158.69 days. So dosto, you can see my friends that at 21 days, which was after the completion of 3 weeks, I am able to give a claim shelf life for the 476 days. So my friend, this is the thing where you can find like the trouble. When you were doing at 5 degree, we were able to match with the exact 395 days, but in this case it becomes 476 days. So that rationalism is not able to justify where you should, what will the set point, right? So I hope it is clear, my friends. When you accelerate your product at a high stress condition, the number of time points would get decreased. I mean, the number of rounds to perform the accelerated stability study on the product will get decreased. I mean, the frequency. Whereas when you keep a stress condition at a lower temperature, you need to perform your accelerated stability study for more than a couple of weeks. So what is the conclusion, my friends? As I told you, we were working on the RT-PCR based product which was having a claim shelf life for 12 months at a 20 degrees Celsius, my friends. So in this case, the X kit will be subjected to a temperature of 5 degree for the 70 days, which was the 10 time points, whereas at 25 degree for the 21 days to achieve the claim shelf life of 13 months, my friends. So I hope you must have enjoyed my today's lecture. Please do like my video, comment, subscribe and share in your valuable network and help in growing my channel, my friends. Till then, thank you, take care, bye bye.